Hi everyone. How to understand that your infrastructure is hacked? We ask that question all the time at this conference, and first of all, we are glad to welcome you, to meet you at the biggest event dedicated to cyber security. So how to understand that your infrastructure is hacked? We will tell you about our experience, the experience of our company, Veriform, and how we address that problem. Let me introduce myself. My name is Konstantin Vasilyev. I'm a leading SOC-RT Protect analyst. I have 6 years of experience of investigating different incidences. Oleg Slipushenko is the second-tier analyst, and also he is investigating into the incidences and automations, the compromise assessment. And this is something we are going to discuss. A year ago, an decree was signed, Decree 250, which contained terms of reference to do some works to protect cyber infrastructure. And apart from the analysis as to how well the infrastructure is protected, it contained another objective: to look for successful compromising of critical infrastructure by the malicious agents. As we understood, this is very objective for a compromise assessment department for many organizations. It was a need, it was a must to follow that order. We started addressing that problem, and we will show what we have achieved. So let's agree on the terms. Compromise assessment is a retrospective analysis of the infrastructure to understand whether it was compromised or not. We will find not only the current active threats, and we have to highlight them, but also we have to identify the attacks that were made before. And therefore we have to make timelines of these attacks and to highlight all the bottlenecks in the infrastructure of the customers. Compromise assessment implies 4 stages. First of all, that's about planning, scope of the infrastructure, certain documents, preparation of tools, etc., etc. Then it is followed by the data collection or data acquisition, analyzing not only the end-user systems but also means to protect the information. It may include also interviewing the administrators and many other things. So we are collecting the data about the infrastructure. Then it is followed by the analysis of that data. We find malicious activity, whether it is going on now or the past one, and we have to come up with a report. This is a general understanding as how we understand the compromise assessment process. When rendering that service, we encounter the following problems. First of all, it's very difficult to analyze big infrastructure. How to analyze, for instance, 10 hosts or 100 hosts or 1,000 hosts. How you launch, how you run tools, what tools have to be run, and certainly, ideally, this has to be one tool, but usually there is no silver bullet. Therefore, that would be a set of tools. As a rule, they are diverse, they are not homogeneous. You can develop everything on your own, but you'd rather use some available means. There are different tools that would give you certain different formats of data that would be run differently. You have to analyze that data, and as soon as you do something for one infrastructure, you will come up with another problem with another type of infrastructure. We came up with RT Retro solution, which automates the data collection, automation, optimizing of the tools used in order to collect the data, automation of enrichment of data, and optimization of analysis process. Again, there is a problem. Lots of hosts, lots of tools that all turns the work of the analyst into some routine. So it means that our project, RT Retro, aims at helping the analyst avoid mistakes and avoid human factor impact. So that's a question of automation of the processes. The tools would depend on the end user systems. For instance, these would be the administrators. Machines were the domain controllers, so we identify the critical nodes, and for them we have to collect ample data. And for the big data, actually, we can collect only some milestone data, some top-level data, and after that we would seek abnormalities. We automate not only the data collection but also the analysis process and normalization. The first question that we face is about the choice of tools. How do we collect the data? Ideally, as a person who is interested in getting to all the bolts and nuts, but now it won't be so cool. Therefore, we have to use different tools to collect the data. And for that, we have developed certain criteria. Signature analysis of the file system has to be done. We have to do the correlation of logs, statistical analysis. In essence, we have to collect the data that would act as beacons for us, and these would be some red flags, some milestones, and then we would go deeper into the data analysis. Saying that, we have to bear in mind that for critical infrastructure we have to do a deeper analysis of the hosts. It means that we have to collect much more information from the hosts, and that would imply collecting all the logs of OS, the file system, processes, services information. This all has to be collected. The scope of data for critical infrastructure would be much bigger. We have identified several directions where we are going to look for tools. We have to analyze web servers. We have to collect the basic artifact data. We have to do IOC scanning, analyze the files. Also, see the persistence, live memory acquisition. And we have certain tools for that. And also we do the log analysis. What criteria we have for selecting the tools? That's about the ample data to be collected. There are lots of tools, but they have to provide for the ampleness of the data. There should be no gray zones in the host data. Once you do an in-depth analysis of the host, there would be even less gray zones. But certainly you cannot collect all the data, all the information, but certainly you can prioritize that and identify the most important tools, depending on the system. And there should be no overlapping. You should not use two tools in order to collect the same data. For that, we were studying what kind of data has been collected by this and that tool, and we tried to ensure ampleness for data collection. Also, we had to do the CSV or JSON format for further processing. As far as if we collect only the initial data, the volume of the data collected would be too huge. But if part of analytics is done right on the host that you analyze, then the final archive would take dozens of megabytes and would contain the most important data. And then, for instance, you can do further investigation into that, but it would contain certain milestones. And the open source, that's the final criterion. We wanted actually not to spend too much, and moreover, now the tools available allow us to do that. We came up with the following selection of tools, set of tools. Part of them are open source, and certainly some of the problems were to be addressed by our proprietary tools. So it means that some of the tools were designed or developed by us, but most of the tools are open source ones. The ones would address the problems that we have identified. There would be compromising indicators there. Signature analysis, a web server, and other things could be analyzed. So it means that we can address all the problems there. And again, the list is not full. Saying that, I suggest to proceed with more detailed analysis of our project and I pass the floor to Oleg. Thank you, Konstantin. As we said, we can highlight several stages of retrospective analysis. First of all, the collection of data, identifying the most critical elements of infrastructure, data collection. Yep. Can you hear me now? Yep. Normalization of the data collected and the further analysis. That's clear. But it should be noted that any organization which render the services of the retrospective analysis also would normalize the data, would collect the data and subtly but we'd like to show our vision, to show our solutions. There are 7 stages pertinent to the retrospective analysis, so we deploy that process. And so that we'd like to show to you some technical aspects. Let us proceed with a stage-by-stage gradual analysis of our cycle. First of all, we identify the critical nodes of infrastructure. The host of most of the alerts or other ISS information security systems. It would depend on the infrastructure of that specific client, on his or her resources. Now, it's quite obvious that probably we had some preliminary analysis, and now we get the information about some hosts that were involved in some malicious activity that suffered some attack, and certainly this would require a lot of flexibility when analyzing the data. We can see that, for instance, there are several servers in DMZ, and the customer would like to do a retrospective analysis of Exchange, and the tools used for Microsoft Exchange probably would be too excessive to analyze the hosts, because, for instance, the tools enriched with the signature base will not comply with the host of users, for instance, Jara rules or Sigma was added to that tool, and it doesn't make sense to upload that data onto the user segment, because probably it even doesn't have a postal agent. Let us proceed with the second stage. A centralized running of the data collection. As I said, right now, we have to identify what tools we want to see on this or that node, what data we expect from the operator. There are several methods that the client may use in order to collect RT-retro data. For instance, we can use the command line, the list of the necessary tools, or you may use the basic tool of toolset, Exchange, Advanced, and Full set of tools, which would provide for the full range of tools available there. Although the process itself is quite well automated, still the users have to upload the initial files and update the signature base. We wanted to somehow automate that process by means of pipelines, CI, and GitLab. Means that the operator doesn't have to do anything but indicating the name of what has to be collected when certain pipelines do their job. You get some exe file, which is regarded as the ultimate result of the GitLab CI work. Finally, we can proceed with centralized launch of data collection. This can be done by Active Directory, group policies, Kaspersky Security Center, and other means of remote administering. End of the day, we would get the data collected into files. One is a log data that would collect the RT retro process data, and the data archive. The name would contain a tag of the tool that was used in order to collect the data. Then it would contain the host name and the date when the access to information was provided. Okay, we have collected the data, but there is a problem there, in the sense that almost all the means, all the tools that were used to collect the data have their own exhibiting format. All the open source solutions were developed by different groups of people. They would have their own vision as how information has to be shown. And that's a very rare case that utilities have the same output format. And therefore, it necessitates normalizing the data. What normalizing of data is about. In the context of our project, we use a patch file as a normalizer, as it helps to quite easily scale up that data. It might be useful for the people who are not familiar with the full cycle that we're speaking about, but who want to start dealing with that. It's not so scary within the Apache format. The above-mentioned things are applicable to Linux systems. But within today's presentation, we will consider only RT Retro Windows. Let's take a deeper look at RT Retro Windows. It's not a very legible slide, but the customer has several methods of delivering the collected data to our infrastructure. For instance, keep reminding me to get closer to the mic. RT Retro has an incremental replenishing of the output data from certain archive. It helps to automatically start analysis of data even prior to when RT Retro has done the job. There might be a lot of utilities, and within a big infrastructure, it may take several hours if the incident requires an instantaneous analysis, and every second counts, and RT Retro gives us this opportunity. After you get the data into your iPatch IFI, it would be deployed and would follow certain graph, which contains in the structure the so-called processors, such as normalizers, where everyone would be responsible for its function, unpacking, parsing, bring that to the common format, renaming of the fields. The most important thing is that the timestamps have to stick to the common format so that we could make timeline events. Next, the data JSON document would be transferred to the database, but at that stage we decided to get maximum of information. It would be quite legitimate to assume that once there was some malicious activity detected, then it means that it would be some malicious software being used, and that is contained in Alienwall or virus total database. So it means that we have to enrich the data. That enrichment already took place, as you see on this slide. For instance, we know that we are collecting IP addresses and hashes. We can actually scan them in certain databases and get some enriched data, and that enriched data would get back to the IPatch file if we need some further normalizing, or for instance it would be rendered directly to our database. But there is a big deal of unprocessed data. In order to correlate that data, we are using the correlation rules. An analyst may get an enormous amount of data, and it would take time in order to analyze all that pile of data. In order to help the analysts in their work, we are using correlation rules. They help us to make data analysis more flexibly, in the sense that in that case we actually will see the bigger picture, the whole infrastructure, not just separate hosts. For instance, as Konstantin has said, there were HiBus and other tools. They may detect a certain malicious behavior on some host, but sometimes some abnormal behavior could be noticed only within a bigger picture, within the whole infrastructure. And that would somehow help us to zero in identifying the malicious activities, as proceeds from the left-hand side of the slide. And as far as we have narrowed to that data, we enriched that data, we got a lot of data, but still we need to visualize that. It means that we cannot do without manual processing. For that, we have very nice dashboards for each of the tools. We can use them, as I said before, to have a bigger picture of what was going on in the infrastructure using timelines, pie charts, and dashboards. It happens so that even without proceeding with the infrastructure analysis, doing that manually, we may get some preliminary data because of IP addresses, correlation rules, and other data enrichment procedures, and even dashboards, which may showcase some malicious activity. And at that stage, you may even come up with putting together a report, as I said, even without a manual analysis. When we got IOCs and when certain correlation rules were triggered, Konstantin will tell you more about how to put together a report. Well, data analysis was done. We identified malicious activity. We identified the hosts where that activity took place. We made timelines of that malicious activity. We see the persistence points. In the previous presentations, you heard about the long-term attacks. That procedure helps you to repel such long-term attacks. And we identified some malicious activities, I said. So what we get as a result, end of the day, first of all, we see the overall picture of the infrastructure and the malicious activity going on there now at the moment and in the past. For instance, if an attack took place in 2020, we will show a timeline pertinent to that attack. If that attack goes on right now, everything would be highlighted retrospectively. After we analyze every attack, we would give a recommendation how to respond to that. For instance, if that threat is still going on naturally, we are ready to react to these activities, but engaging new tools. End of the day, we would issue a recommendation how to prevent that in the future, how to strengthen the infrastructure, how to strengthen your security system, how to improve the domain infrastructure, etc., etc. Another example, timeline could be visualized. So the customer would get both the technical information pertinent to every event that took place in the framework of every attack, and he would also get a visualization in order to define the processes when the attack started, what was the entry point, what actions were taken by malicious actors, what malware was run, what files were created, etc., etc. For instance, we will see that certain critical pieces of infrastructure were compromised, such as KSC server, for instance, and after the description of that activity, if it was in the past, the customer will be able to isolate the compromised infrastructure and to prevent such attacks in future. So what results were obtained in such a process? So we automated the search of successful traces of compromising. So we got an automated preparation of the tools. Data collection is also automated. Correlation and normalization of data is also automated. When analyst embarks on the work, the data are presented in a very convenient format, and he would get the whole scope of data. And the only thing the analyst has to do is to use these milestones and use the more detailed data in order to investigate that. Means that the analyst doesn't have to look through the raw data, unprocessed data, but if necessary, some extra data could be collected and in-depth analysis of certain house may be done. Also, we can analyze the process for a big number of customers. It means that we have reduced the hours per customer for the analyst. We are not spending time on some routine work, and it means that the number of analysts goes down. It should also be added that such a project may be used in order to investigate into the combat incidences. Actually, there was such a practice within DFIR in order to identify the scope of the attack, in order to collect necessary data. If necessary, in case of a deficiency of the monitoring system, certain threat hunting could be done. And in practice, that tool proved to be quite efficient, quite effective, and therefore many processes could be facilitated, not just rendering the compromise assessment service. What our plans for the future are? Certainly, there is a lot to be improved. First of all, the data collection should go from RT Retro to Golang, and that would provide for the cross-platform nature, and probably we can answer that question during Q&A session. Then also we can increase the set of tools and this spectrum of data collected. Also, we can customize the project, and we can overcome the current limitations, such as, for instance, at the moment you just get an archive as an output data, and actually can put that into some network folder. But once we rewrite that to Golang, it, for instance, could be dispatched, for instance, using syslog channel. Means that we can improve the project very much. Naturally, we want to expand the toolkit and the spectrum of the data collected, because the data coverage is not ideal. You always want to improve that. Another item there, we have to improve our correlation rules, statistical analysis, and other analytical approaches. First of all, we see some future in improving the correlation rules which are applicable to the host system from which we collect the data, and also the correlation rules which actually are taking place in CIM.
This way, we will use the capabilities coming from this collected volume of data. Okay. Statistical analysis. This is also quite exciting. We see a big scope, a big infrastructure, and we can find anomalies like the unique created files or unique launched files. So there the analyst can be creative and develop some new and fresh solutions. So ways to develop the product are many, and we are ready to fresh ideas and cooperation. Thank you for your attention. Any questions? A question on the solution. Slide 8. Thank you. Slide 8 says, so here you have some trips of the system. So do you collect logs from the system? Okay. Well, we can take it from the host, and there you can have some kind of Windows Defender. Okay, we take it from it. Then we also take logs from other systems, like the infrastructure or the antivirus, say Kaspersky. So we export them and we analyze them, and this way we understand the critical nodes of the infrastructure for more data collection and analysis, and it increases IDS and IPS. Well, indeed, at the preparation stage we do this for profiling the infrastructure elements, and in practice you can see that it is worth looking into. Okay, slide 10 please. This is quite interesting. You say no doubling the tools. So how do you do this? Well, we have a table for the sources of data we want to take from every host, and each build should have this. So we have multiple tools, and sometimes open source tools can take information about the activity of processes and some other things. So we solve the problem by picking the tools by their launch parameters and their configuration. So we prevent overlapping of the collection process. Okay, to make it more clear. Okay, we have two utilities, and they can make various logs. So in the config file of this utility, we just switch off some functions to avoid overlapping, because many data collection utilities, for sure, they can have overlapping functionality. So we optimize this. Okay, thank you. And the final, more general question. How long do you store the information on events? And how do you scale this? Okay, following the compromise assessment, it can be a one-time service. So we analyze the system, we give you the report, and if you don't have any requests for further investigation of active threats, well, we can either store or remove the data. So dealing with our long-term customers, so when we have a plan, we usually store this for 3 years on average. Okay, thank you. Thank you very much. So why are you using Apache for normalization if you can use logs Dashe normalization? Well, Apache on FI is used because it is easily scalable. Like we can add nodes and balancing. Well, there are some other tools to do this, but, well, as I mentioned, you have a low barrier to entry. There, it is a more user-friendly interface. It shows the graphics processors, and you can use button scripts. With the Shen, for instance, you can only use grok parsing, or you can use Ruby code blocks. So Apache FI gives more capabilities. Yeah, and they receive the zip archive as an input, and there you can see the result of work of many utilities. Okay, we can go block by block. Here you can see some schematics of those blocks to the right. So we unpack, we highlight the necessary sources to parse, and where you see the branching, we normalize parsing and we enrich various sources of data. Well, all of this is more visible, easier to scale and to maintain. That's why. And another question, the correlation rules. Do you use your own alerts or your own module? So we use whatever we can, including Last Alert and Yolki and our in-house products. Yeah, for the end systems, we use the standard Sigma rules, so it's compatible, and so we have some plans to improve this, to add something to correlation rules and Elastic security rules, the open source ones, and we have a lot of our in-house rules. Thank you. Hello. Here is my question. Well, RT-Retro is a correlator building timelines, and so you also use information protection system information for the timeline. So you use this flags or tip-offs, and if you didn't have this, then it's not your cup of tea, is it? Well, this is a big project. It has a data collection tool for the end system, so you collect and you launch the tool. It also has a tool to analyze the collected data, normalization and enrichment, the one on FI, and there is an analytical tool there based on Elastic. And the whole thing, the whole project, is called RT-Retro, and it gives an analyst a chance to reduce the labor effort. Okay, so RT-Retro is just a part of information collection. So correlations are not happening at this stage. Well, apart from some deep analysis using some other equipment, some other tools. So RD-Retro is not doing this. It happens at later stages of the life cycle. Hello, thank you. Say you have an attack, some new malware which is not in the threat intelligence database yet. And can the enrichment process somehow conceal this from the analyst? Well, enrichment is not the only thing underpinning everything. It is a very good add-on. So you can have positives or otherwise. Well, as I've already mentioned, we will have to look through the events with our eyes. And it is there to stay for some time at least. And this tool is just a way to help you start analyzing and adding some evidence when you draft the report. But this is not a standalone thing. Yeah, there are many indirect signs of activity. So if you have some new malware, so you cannot identify it using signatures. But you can use some indirect things like the MFT and log traces and other traces and other points. So you can use this indirect evidence to identify it. But you know, it's like the cat and mouse story. Okay, the analyst can see something, but there won't be any enrichment to highlight things. Yeah, this is not a panacea. You don't have this IP, you don't have this hash or signature. And that's why we are gathering information on the process history. And an analyst will have a look at this, will see the trip-off or the flag and start dealing with it. Hello, thank you. I have an engineering question. You have a distributed network, you have branches and so on. How are you going to gather data from the branches? What will be the transport you're going to use? How are you going to package this? How are you going to transport it to an AFI? Will you use Kafka? Will it be a bottleneck? Will it will your retrospective analysis be overwhelming for the infrastructure of the customer? Okay, I think we have mentioned this. So following the centralized launch, using some remote administration tools, we obtain a data archive. And what happens next? How do we transfer this? Well, I have shared an example with you. We can do it in the BN tunnel if we have access to the infrastructure, so we can do this directly. We can deliver the data directly using the tunnel up to our infrastructure. To the server, we will have Apache on FI working. And we can also do it in a standard way. So you manually copy the data to an external drive and bring it to the center. Okay, I think the question is like that. If you have a lot of branches in the infrastructure with the unique features and so on and so forth, okay, this is a common issue. And this is about launching the executive file. It should be launched for the whole infrastructure. This is an infrastructure way. And you also should collect data, and there can be a lot of it. Yeah, we solve the problem by using tunnels. So you can establish these tunnels until a network folder in the customer infrastructure, and you can load all this there. We can do it with the customer. And so when we implement this on Golang, we want to use the new type of secure transport so that we can store all this in the cloud storage. Thank you. And you also asked a question about archiving and compressing information, and this is also done at the collection process. So the gathered data is compressed as much as we can into the zip archives, and the output is usually in TXT or JSON, CSV documents. They are really compressible, and really big volumes following archiving can be okay in terms of size. Well, indeed, the size can be big, and in this case we can use a RabbitMQ. So you talked about Kafka, we use RabbitMQ. So if we have a lot of data, we have workers processing this information. So in this case we won't have any downtime or anything like that. Thank you. And one more question. Are you gathering or planning to gather data from some other places where you cannot install anything when you have SCADA or Internet of Things? So are you dealing with it? So we agreed with the customer. Well, some tools are cross-platform ones. If the architecture is okay, we launch some tools there. We have seen some unusual operating systems, and some tools are okay, but this is really a delicate thing, and dealing with SCADA is something we will have to sort out. So we see whether the host deal with SCADA, or we see whether there are other ways. Thank you. Another question. Hello. Thank you. You say that you collect logs from the information security system and from the penetration prevention thing. So how do you solve the false positive problem? I, for instance, recently had 800,000 false flags, and I understand that they are false positives. So when we start dealing with the custom infrastructure, do you invite the customer to sort out the logs you have collected, or do you follow your own logic? Thank you. That's a very good question, how we interact with the customer. If we have concerns and if the customer is ready to assist us in doing our job, well, for false positives, we can say, for instance, when we analyze them, we discuss it. So if we see activity, we can ask whether it's legitimate or not legitimate activity. More often than not, we do it through some fixed communication channels. So we make a list of things, so we can get rid of some clear false positives, and for the suspicious things, we can coordinate them with the customer. Yeah, the cutoff approach. If the enrichment process identifies some malware IP addresses, then we follow the chain, and we can understand the vector of attack, and maybe we can get rid of some false positives. So we can start the process of analyzing the really malicious IP address and follow this trail rather than consider millions of documents from scratch. Thanks. Another one. Well, you know, it would be cool. Well, not far away from here, the red and blue team are now fighting, and your last but one slide shows a report on RDP, the hops, and how it jumps around. Yeah, this one. So I think it would be cool to take an incident performed by the red team, so you could come there with your solution, and you would see what works. Well, together with InnoStage, you could see whether the system really works well, because it looks cool, but we understand, well, this is difficult to do in practice. Yeah, indeed. Yeah, this experience has already happened. We have participated, we have used the monitoring system, and we have used some solutions shown here. We have had this experience, and indeed we are going to do it again. Thank you. Hello, thank you. I have a question on big infrastructure. If we have more than 3,000 hosts, and if they are distributed further than just inside Russia, beyond Russia, do you have any ways for automation Not all the hosts are managed by centralized policies. They have any ways to analyze their infrastructure preliminarily, and based on your experience, how long will it take to analyze this number of hosts? And do you analyze workstations of the users if they're used as servers? Okay, I got you. One by one. The case with foreign companies. Well, I mean with foreign branches. Yeah, let's put it this way. Yeah, we haven't had any case like that, but I cannot see this as a big problem. We are going to implement a cloud solution so that we have this option of sending the results to our cloud or through the VPN tunnels. You can also feed this. Launches. In order 250, you have analysis of protection and retrospective search. We have this practice. We usually do it together, and following the protection analysis, you can see the external perimeter and the internal perimeter, and you can have a full picture. And sometimes, following the results of this protection assessment, we can build the scope. And this way, we find some assets, and some of them can be undocumented, and we can see some surprises for admins, that here is your forgotten server, and so on. And the question of centralized launch. Yeah, launch for a lot of hosts and the volume of the hosts. Okay, the launch. This is an engineering task quite often, so it depends on the infrastructure. So if you have AD, if you have KC, okay, we launch it. So we also have a script which uses some remote launch methods like PowerShell, RAM or PSExec. So it uses several options there, and there you give the host and the credentials if you don't have the domain or if you don't have the other tools. So you have this rainy day tool. So just the list of machines, and you give access to them. Yeah, okay. Okay, we have workers, and so we have incremental archive top-up. And this is good for the server processing this information. So it receives 2 GB or 10 GB. They have been processed. And while it is being processed, information is being collected from the infrastructure, and only the new increment of data will come to the server. But you have analysts at the final stage, don't you? Yes, we do. And do they have more load? Yeah, sure. If you talk about load on the infrastructure and the servers. Okay, it's clear with the infrastructure. What about analysis? How long do you think this retrospective analysis would take for 3,000 hosts? Well, it depends. It might take about 2 weeks, more or less. But if we find, say, dirty infrastructure, this can take longer. Say, we'll find some hotspots here, there, and there. This will be large-scale work on a lot of infrastructure with many holes in different parts, with some attacks which can be more advanced or less, and this can take a long. And this is something the customer should understand. So it's not enough just to engage with this 3 months, like you make it clean in 3 months. But if you don't install a full-fledged monitoring system, if you don't follow the recommendations, all of this will be to no avail. And this is both retrospective analysis and introducing a monitoring system. Only then it works. And talking about the scale, quite often the infrastructure is segmented, and you just deal with it segment by segment. It's clear. Thank you. Hello. The last question, please. Yes, I have two quick questions. Number one, have you assessed the role of every tool and its contribution to the detects? And the architectural question. The use of external tools and packaging them into the Excel, well, then you launch AD in the Windows, but you have some group policies already, and you can do this checks for the whole domain, and then you'll have this normalized results from every inspection. So why did you develop this architecture? Could you repeat your first question, please? Yeah, did you assess the contribution of every tool? Okay, the contribution, indeed. That's why we have the builds, the basic, the web server, and the advanced one. And this is to understand the contribution. So the basic one has the lightest and strongest signature analysis and quick correlation of logs with the end system. And the same works for Simcache. It takes information quickly, but it's a minimal information, but it's one with the highest contribution. And this is how we determine the basic build. So they're the lightest but the strongest tools. So we have this analytics, domain policies, infrastructure analysis works like that here. We cannot take everything with the domain policies, and quite often it's more difficult to look at them rather than to take structured information from every host. Well, this is subject to further discussion. I think we'll pay more attention to this. Thank you. Yeah, if you believe that most of the contribution comes from the inbuilt solutions, so why do you need this complexity? Well, these inbuilt solutions, we need to clarify what you are talking about. Okay, thank you. This is a great question. Good. The t-shirts. Yeah, the last one on domain policies. Yeah, why not? This is another good idea to think about. And the second one is about archiving and data transfer. Is it you? Could you please? Okay, I think that's where it ends. Thank you very much for your attention. Thank you for your great proposal.